This is precalc. This is 2.6. We're going to talk about extremes of functions. We're going to find max and mins. There are two types of problems that we're going to deal with. Most of the time, this lesson is actually going to deal with just quadratics. And I'm going to show you two different ways to find the max and the min of a quadratic. One of them you guys have used quite a bit. This first one, though, that we're going to talk about is using vertex form. The book actually calls that the standard form of a parabola, which is kind of messing up with what we have been keeping with over the last several years. And then the last one is you can actually use your graphing utility and look for local max and local mins when it's not a quadratic. And I think we've talked about that before as well, where if a graph has many turns and dips, there's usually one that's higher or lower than the others, and we'll call that the local max or min within a graph. So today we're going to focus on, right up front, is quadratics. And the book, again, starts to change things up on us on our wording. They're trying to say that this thing of ax squared plus bx plus c, which we call standard form, they're calling that the general form. So be careful in the directions. When you see something, you're like, isn't that already in standard form? And they're asking me to put it in standard form. It's because they would call that the general form. Now, if you remember, most of the time, if anything, all the books that you guys had or what we've been working with, general form has always been where the equation would be set equal to 0, which means everything like constants and everything are brought to one side. So when you had, just to kind of give a quick example, standard form of a line, if you remember, is ax plus by equals c. But then general form, they brought c over, and they have still positive because it's a constant. We don't know what it is. But that second one there would be called the general form, where it's set equal to 0. So just be careful on the way they're going to ask the question. I'm still going to keep with tradition of what we've been using. That means that the second definition there, or the second form of a times the quantity x minus h squared plus k, the h and k, a, h, and k, transformational form, which we've been graphing the last couple days, we call that the vertex form. The book now calls that standard form. Okay, so be very, very careful. Now, some information about this is the fact that you know that h and k is your vertex. And the really cool thing is this, which k is the second one, the second value, is the maximum or minimum value at h. So it's going to ask you, hey guys, what's the maximum value of f? It's not the whole entire vertex. It's just the y value of the vertex. Remember that. But it's at h. So parabolas either open up for us or they open down. So if it opens up, a has to be bigger than 0. We should know that. And k then is a minimum. And vice versa. If it opens down, then h is a maximum, or k is a maximum at the top, because your vertex is on top. Make sense, guys? And then I have it here, and we're going to do this on this next problem, which is on the next page as well. It says we can switch from standard form to vertex form just by completing the square. And that's, again, why I put that last problem on your worksheet yesterday. And the fact that I wanted to see if you guys could pull out that completing the square stuff and see if you can remember how to do that when y is there and versus not being there. So we have to do that today for this particular problem. It's on the next slide, okay? Any questions? It's all a recap so far for the most part. So we got expressing a quadratic parabola in vertex form. The book would say standard form. Consider the following quadratic function of f of x equals 5x squared minus 30x plus 49. Part A says, I want you to put this into vertex form. Part B, then, I want you to make a sketch. Now, When I say sketch, we do not need to go through the whole parent, family, child for it, okay? Unless I say graph using the parent, family, child, which very well could be an option for this type of problem on a quiz. Think of this. I could give you a problem like this where it says find the max or min problem, which means that you convert it, you can graph it, and then you can tell me something about that graph. So I can start to lump problems together so you don't have to do 17 of each type, right? Now, and then find the value of f, the minimum value. How can we automatically say this is going to be a minimum value? I know this is going to be minimum. Why? Because 5 is greater than 0. 5 is positive, and 5 is a, and therefore it opens up. We know that this graph will look like this, and so our vertex is on the bottom. It's a minimum. So, here we go. What's my first step in completing the square? Can't put a blank yet. Subtract 49 to the other side. I like that. I'm going to do that right here. So I have f of x minus 49 is equal to 5x squared minus 30x. Is everybody okay with that? Now, what do I have to do? I could factor out the 5. That does work. I find that this, by factoring out the 5, leads to problems. So I am actually going to suggest dividing both sides by 5. Okay? I'm going to suggest that you divide both sides by 5. Now, what this does create for us is f of x over 5. Eventually, we will be solving for f of x again, so we'll have to get the 5 out of there. But this will allow me to complete my square in my own mind a lot easier. We'll just say minus 49 still. And now this equals x squared. Actually, I'm going to leave some space in here. Equals x squared minus 6x plus something, right? I'm actually going to do it to both sides. Why am I going to do that to both sides? Yeah, what I do to one side, I have to do to the other. And the next step for completing the square is to add what? It is going to be 9, but it's half of b squared. I'm not going to write 9 on both sides. I'm going to put negative 3 squared, and then I'll put 9. Do you guys remember why I put negative 3 squared? Because that's the value that goes inside the perfect square binomial. Because the next step is to factor it. So that is the completing the square part. But the problem now is we have to combine that stuff over there. Maybe I should separate the f of x over 5 and 49 over 5, yes? And get a common denominator. Minus 49 over 5. What would 9 be in fifths? This is really 9 over 1. 5 and 5. 45. 45 over 5. So f of x over 5 is minus what? It's negative 49 plus 45. So it's 4/5 equals x minus 3 squared. 2 steps left. Now I just have to solve for f of x. How do I solve for f? for f of x. I could multiply by 5 right now, or I could add 4/5 to both sides. I see that I am going to run out of room. Is that everybody okay with me just adding 4/5 to both sides? Because these will cancel each other out. Now the last step can be multiply both sides by 5. Fives cancel. F of x equals 5 times x minus 3 squared plus 4. Okay, now let's go back up to this step real quick. At this step right here, I chose to divide by 5. The reason I chose to divide by 5 instead of keeping the 5 there or factoring it out, because technically, yes, I should have possibly, potentially done this instead and factored it out. Because 5 times the quantity x squared minus 6 is the same thing as 5x squared minus 30x, correct? Now, the reason I chose not to do this is because at this point I can complete the square, and yes, half of negative 6 is negative 3, and I'll have to square that. So I have to do that here, and I'd have to do it all the way over here, like we did at this step, right? We ended up getting 45. The problem with an a value that's out front is that I'm not really just adding 9 on this side, because there's a 5 out front. That 5 would have to have been distributed in, which would have been 45. A lot of students forget about that in general. And so I like to just get rid of any values of a that are not 1 to make it easier for myself. It does create a couple extra steps. But if you were good enough, or remember that if you have something outside of parentheses, it has to be distributed in, that's the total value you are adding on one side. That's the you would have to add to the other side, which would make 45. Then you wouldn't have to worry about common denominators and doing all of that fun stuff. So that's 2 different ways to complete the square. You will end up with the same equation though. So now the next part is sketching the graph of that. The nice thing about it is that by just looking at this, you know where the vertex is. Where's the vertex?
3, 4.
It is at 3, 4. That is the vertex.
Wait, is that negative 3?
It is not going to be. It's always the opposite, remember? H is...
Would it be negative 4?
No. K is always what it is.
Oh.
But since it's with x, it's always the opposite. Because remember, we're going 3 to the right, right? So it's 3, 4. So when I go, and I know this is opening down, 1, 2, 3, 1, 2, 3, 4, we know that that's my maximum value, or my maximum point. From here, we know it will fall. Sorry, it's opening up, sorry. Wow, that's your maximum value. So it would go up from here. Now, we could use other context clues here. The fact that you are given this in standard form. You can easily look at this top equation. Where's the y-intercept? Where's the y-intercept from this thing? It should be 49. That means way over here, way up there, it crosses the y-axis. Which means, which is 3 steps that way, 3 steps in this direction, is also way up there. For my particular graph, that would not be very good. So I may have to stay a little bit closer to home. So maybe what you'll need to do in this equation is put in something like 2. put in 3. But 4. 2 and 4, though, will end up being the same value. What's 2 minus 3? Negative 1 squared is 1. 1 times 5 plus 4. 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Something like this. Oops. So there's your sketch. Sketches are not perfect, guys. But we should be able to use that graph and say, hey, I know the minimum value. Minimum value? Minimum value is 4 at what?
3.
At 3. Can you guys get what that's trying to say?
Wait. Just a contract. Where's the 9, like, for the, in terms of x? Or y? Like 9.
9 is your y value.
Yeah, but how far away is the x? Oh, 2 and 4.
2 and 4. 2, 9, and 4, 9. So, you have a minimum value of 4 at 3. So your k value is 4 when your h value is 3. Or it's the point 3, 4. It's a vertex, guys. Your homework, we'll finish this lesson up tomorrow, is page 204, 15 through 23 odds. This just follows the completing the square, sketching it, and then finding the max or min value. Have a great day.